Good afternoon, everyone, and thank you for joining us this evening. On behalf of the AAPG Young Professionals Trinidad and Tobago chapter, I'd like to welcome you to our talk this evening, Data Science in Oil and Gas, with Kadija Hassanali. So, Kadija has more than 4 years' experience in the oil and gas industry. After undergrad, she worked as a reservoir engineer in Houston for about 2 years. She has been a data scientist with BPTT for the past 2 years, working on digital projects across the organization. Khadija has a Bachelor of Science in Chemical Engineering with a minor in Biochemical Engineering from the University of Delaware and a Master of Science in Reservoir Engineering from the University of the West Indies. When not in front of a computer, she can be found trying to complete clothing fitness challenges or watching Netflix. So, once again, thank you for joining us. Feel free to put your questions in the questions and answer pane and we'll address them. And Khadija, I invite you now to share your screen and take it away.
Thank you for that very nice introduction, Tarek. Okay, yeah, so let me just share my screen and let me know if you all can see. Okay, so 2 seconds. Okay, now I just need confirmation. Are you all seeing the presenter view or are you all
Y-
seeing?
Yeah, you're good to go.
Okay, great. Cool. So hello again, everybody. Glad you all could make it. So as Tarek said, my name is Kadija Hassanali. And today I'm here to give you all an introduction to data science in the oil and gas industry. Now, the first question I'm assuming on many of your minds is, what exactly is data science? So the important thing to note is that Harvard Business Review called it the sexiest job of the 21st century. Unfortunately, though, the models that you work with on a daily basis don't look like this. Rather, the models look like this. I really hope that got at least one chuckle out of somebody. I really do. But seriously, what is data science? So, I read a comment that said data science, like describing data science is like trying to describe a sunset, where it should be easy, but somehow capturing the right words is impossible. Um, one definition I've seen is that it's the art of turning data into actions. Now, as you can see here, data science incorporates, a wide range of disciplines from math and data engineering to things like domain expertise and coding and computing. But the real takeaway is that the goal of data science is to gain insights and knowledge from any type of data. And I use the terms structured and unstructured data. So, structured data would be data that you can find in tables that can be stored in rows and columns. So, numerical data, dates, strings, all that is considered structured data. Unstructured data would be things that can't be stored in a database in a table. So, things like video files, images, audio files, etc. But the whole point of data science is that it it helps improve a business by providing actionable insights from data. And that is accomplished through the creation of data products. Now you're going to be like, Kadito, what the hell are data products? So, data products are any application of data that provides value to a business. So, it includes different types of models, data models. So, you might have a predictive model. So, an example of this would be that we make a predictive model that tells BPTT how much gas it's going to produce in 2021. So that'd be an example of a predictive model. A descriptive model would be a data model that finds and explains some trends in the historical gas production of BPCC over the years. And then a prescriptive model might be a data model that says it's best that you allocate this amount of gas in each of Atlantic's trains in the year 2021 based on the fact that you're going to produce X million scuffs of gas in total in that year. And so that's just an example of the types of data products that are produced via the data science process. And I guess another question you'll probably be asking is, so why should I care? Why is data science so popular now? And the reason for that is twofold. So the first of the reasons I've highlighted here, which is that we produce so much data on a daily basis. So, one statistic that really surprised me is that 90% of the world's data has been created in the last 2 years. And humans produce 2.5 quintillion bytes of data every day. And a quintillion is 10 to the 18. And this is not just in the oil and gas industry. Looking at things like Instagram, 95 million pictures and videos are shared every day. There are 300 billion emails sent daily, 5 million tweets. So, data is everywhere. We as humans generate tons of data. And then the other reason, kind of that move parallel to the fact that we generate a lot of data, is that computing power over the last couple of years now allows us to process this large amount of data much more efficiently than in the past. So, for example, for BP, there's a high performance computing center in Houston, and the processing power of that computer is 9 petaflops, sorry. And you'd be like, what the hell is a petaflop? So, a petaflop is a processing speed of 1,000 trillion floating point operations per second. And I think it's probably the fastest supercomputer out there, right? So those are the two things to keep in mind: the fact that there's a ton of data and we now have computing power to efficiently process and extract value from that data. Now, I'm assuming another question that you'll be asking is, okay, that's all well and good. Why should we care about data science in oil and gas? And there are two words really for this, and those are big data. So the oil and gas industry generates and kind of deals with what we know as big data in almost every sector of it. And big data is characterized by five properties, which are listed here. So they're volume, variety, veracity, velocity, and value. Very terrible tongue tire. And I'm just gonna go through each one to kind of link it back to how it comes to play in oil and gas, and specifically upstream oil and gas. So when we think about the volume of big data, we're thinking, a lot, just a lot of data being produced. And we see that, in exploration, where, if you've ever seen the data that comes out of a seismic survey, it's gigs upon gigs of data for each seismic volume, all to develop, 2D and 3D images of the subsurface. During drilling, we have logging while drilling and measurement while drilling. Those tools and techniques transmit data to the surface in real time during drilling operations. And then throughout the life of an asset, talking about the production phase of things, we have sensors coupled with optic fibers that transmit and stream data from wells and from kits on platforms, on things like pressure, temperature, rates, composition, etc. So, it's undeniable that the oil and gas industry generates a lot of data. And then we also generate a large variety of data. So, as I said, seismic images are just that, images, or seismic attributes might come in kind of numerical format. We have text data, there's audio, there's time series data, which is, various properties measured against time. We see all of that, very typically in upstream oil and gas. The veracity refers to the quality and the usefulness of the data as it pertains to making business decisions. And, going back to seismic, as I know my audience is, Jews, I know you all love your seismic. Going back to seismic, when you think about, getting good data from a seismic survey or getting good quality data on a seismic survey can really impact, can really impact the results of seismic processing, and thus impact, where a company decides to drill next. So the veracity of the data is incredibly important in our industry. In terms of the velocity of big data, again, just go back to a drilling scenario where, you need to understand things like, where your drill bit is, pressures, etc., in order to make sure that, you identify things like kicks, and prevent safety incidents like blowout. So in that scenario, being able to process a lot of data really quickly is vital. And then the final thing, which is by no means the least important, is value. And there's this quote that I found from Mark Mills, who's a senior fellow at the Manhattan Institute, which is like a think tank in New York. And he was referring to shale, specifically to shale production, but it really can be expanded to all oil and gas. And it's saying that, bringing analytics to the various complexities in kind of shale production can result in doubling output per well and cutting the cost in half. And it may not be those exact figures, but it's the same thing, really. Taking advantage of the value of big data can significantly impact, um the profitability of upstream oil and gas. Okay, and I'm going to give you all a little bit more in terms of, some examples of how data science has been used in oil and gas and kind of the benefits. So when you think about data science in oil and gas, you think about real time, cost effective solution. So I don't know how many of you all are aware, but companies pay huge amounts of money to companies like Microsoft, for example, for cloud storage in order to store all the big data that they're generating. And data science and big data analytics makes it possible for those companies to get a return on that investment in kind of data infrastructure. Because data science allows you to extract value from data, it means that the companies won't just be paying for storage without getting anything back. So that's one of the big benefits. The other thing is around reduction of risk and better decision making. So yeah, data science techniques can help reduce risk and help you learn more about your geological subsystems, increasing accuracy in decision making. And what are some examples of this? So I've seen in BPTT, for example, using data science to create proxy models of full physics, 3D reservoir simulations. You have proxy models that will give you kind of post-water breakthrough performance extremely quickly. We're talking about in a matter of seconds. Um, so you can better manage your reservoir via that. There's also a project that I've seen called Fossil Vision, where it's literally an app on your phone, and this is using data science techniques. An app on your phone, you take a picture of a fossil, and you're automatically able to classify that particular fossil. I worked on a project where similar thing. We designed an app, and you take a picture of a sticker on a BP aircraft, and then it tells you the exact fuel that needs to go into that aircraft. And refueling is safety critical. So, it's all about reducing risk, and making better decisions. In terms of increased accuracy in drilling and oil exploration. So I'll talk a little bit later about one of the ways that data science has been used to improve the efficiency of processing seismic data. So that's one example. Another paper that I read shows where neural networks, so a kind of a machine learning that's typical in data science, was developed that could replicate the decisions that an experienced directional driller would make within a really small margin of error. And so in that way, they use data science to automate kind of where to steer the drill bit, and really minimize the risk in that. Um, There've also been examples of machine learning to predict direct hydrocarbon indicators, discovering patterns in geological data. I could go on. And then the last thing is around ensuring efficient machine performance. So because machines usually have sensors that that then allows you to have a history of the performance of that machine. Data science techniques can be used to build a data model that'll actually predict when that machine will fail or under what conditions that piece of kit will fail. And as a result of this, operations can determine good predictive maintenance schedules. So that's just one of the ways that the data science can be used to manage machine performance. So yeah, so those are some examples of how data science is used in oil and gas. I know you're probably thinking, but Khadij, what exactly do you do? Like, what does it all mean? And to be honest with you, what a data scientist does varies from industry to industry, from company to company. Even for me, what I do, it varies from project to project. But overall, there are the four things that I've listed here. And each of these comes with varying kind of degrees of efforts. So the first thing, which, the obvious thing is, get the data that you need to do the analysis. Um, and this seems trivial, but a lot of the times, one of the major stumbling blocks I've seen kind of in industry is that oftentimes, because machine learning, for example, requires a large volume of data, oftentimes you don't have enough data at your fingertips at the start of a project to do kind of the analysis that you need to do. And then you have to do things to get around that, such as creating synthetic data. And I'll talk a little more about that later on in an example. So after you've acquired the data, and you're kind of increasing in effort, the next thing you do is prepare that data. And that's what we call data wrangling. So it's cleaning the data, manipulating it. So for example, if you have a lot of blank values, how are you going to fill those blank values in a table? How you're going to change the format of the data to what you need in order to do the third phase, which is analyze the data. Now, this part of it is the most time consuming. It's iterative. It involves a lot of experimentation. So depending on the question you're trying to answer, depending on what the solution is that you need to get to, or the criteria for success of a particular project, you can spend weeks to months just going back and forth between trying an experiment, testing it out, evaluating, saying, oh, this is terrible, and going back. So the analysis part is the most time consuming, but it obviously will produce the greatest value. Now, I mentioned here, you use supervised and unsupervised machine learning techniques. So I'm just going to define some terms for those who aren't familiar. So machine learning is really about computers learning from data without being explicitly programmed to do so. So that's just a simple definition of machine learning. When we talk about supervised machine learning, those are things like that. An example of supervised learning would be classification. So, for example, you have some images of flowers and some images of dogs, and you have labels that say, okay, this is an image of a flower, this is an image of a dog. You give that information to a machine and it learns how to classify flowers versus dogs, so that if you give it a new image, it'll be able to tell you if it's a flower or if it's a dog. In unsupervised machine learning, you have unlabeled data. And in unsupervised learning, it would be you'd be doing things like clustering, where so instead of having labeled pictures of flowers and dogs, you just give images that are unlabeled to the algorithm, and it's going to determine the features that make a flower and a dog, and it'll therefore be able to separate the images that are dogs and flowers without you having told it what is what. So that's what I mean by supervised versus unsupervised. And you can use a combination of any of supervised or unsupervised machine learning techniques during your analysis, depending on the problem you want to solve. And the fourth thing, which it has here, it's kind of low effort, but it's of huge value. It's acting. It's turning the data and the insights that you get from your analysis into actions. What separates data science from, something that you do on a weekend that you just do for fun is really being able to to produce actionable, impactful insights that you can then take to your stakeholders so that they can make material business decisions based on what you've provided. And that is really the holy grail of data science. What is the impact of the insights that you have generated from the data on the business? Oh, I'm talking a lot. Okay, so now I'm just going to take you all really briefly through two projects that I've worked on so far that I thought were interesting, especially the first one as it has to do with geoscience. And I'm by no means a geoscientist, so I'll probably say things wrong. You all could tell me, when we have the question part of this. So the first project that I wanted to talk about was multi-attribute seismic analysis with Kmeans clustering. And I will define what Kmeans clustering is. Just to give you a preview, it's a type of unsupervised machine learning technique. So you guys know much better than I do that in exploration, you have huge volumes of seismic data that seismic processors will analyze and screen, often under time and resource constraints. Now, as I said before, machine learning enables computers to learn from data without being explicitly programmed to do so. And machine learning then can address two of the challenges in for seismic interpreters that they encounter when trying to process large volumes, which is of course passing huge volumes of seismic data. Machines can do that much quicker than a human interpreter possibly can. And then also, when you think about the multitude of seismic attributes that you have, that human interpreters need to make a connection between kind of all these seismic attributes and what the combination of them means in the bigger picture. So machines can analyze things in a higher dimensional space much more easily than us humans can. And so understanding the relationship between various seismic attributes is much easier for a machine compared to an interpreter. So this is just an example of the workflow that I use during this project, right? So as I said, I'm not a geophysicist. And one of the things that data scientists have to do is leverage the expertise from the people that they're working with. So I worked with a seismic processor geophysicist to come up with a combination of seismic attributes that you see listed here, that I would use. And then I took those seismic attributes, so literally took for each X, Y, Z position in space, the value of these seismic attributes at that point, and inputted it into the K-means clustering algorithm. Again, I will explain what that means in the next slide. And as a result of using this K-means algorithm, I got clusters, I got patterns. The algorithm found patterns in the data that actually represented geologically significant things. So, for example, the volume that I used had direct hydrocarbon indicators like a flat spot, for example, and the patterns that the algorithm found were able to map to things like this flat spot. Again, I will show that in the next couple of slides. I then incorporated some saturation log data to produce a 3D saturation model of that particular seismic volume. I guess the thing to note is that in the analysis, one thing that I had to be careful of was to avoid using seismic attributes that had really strong correlations with each other's, in order to reduce any bias in the algorithm that I was using, that K-means clustering algorithm, and also to keep the model simple, because a lot of times with the data science, because the algorithms tend to be black box, it's really difficult to explain, why the algorithm did what it did. And then if you're basing business decisions on this algorithm, it's not good enough to be like, oh well, the model told me that. It needs to make sense. Experts need to be able to interpret and understand why the model outputed what it did. Okay, now what you've all been waiting for. What the heck is K-means clustering? So as I said, it's a type of unsupervised machine learning algorithm. So that in this case, if each point here represents a point that has an XYZ position and various values for each of these seismic attributes, so this is high dimensional space, the K-means clustering algorithm will find patterns. So basically, the centers of these clusters will move until until it finds clusters where the distance between each point in the cluster and the cluster center is minimized. So in effect, it's finding the best patterns or best clusters in that high dimensional data. And so each data point, as I said, in the seismic volume was allocated to one of these clusters or allocated to one of these patterns. And as a result, I got this where 40 clusters were generated. Six of those clusters related to kind of geologically important features. So for example, cluster 15, that cluster mapped directly to the flat spot that you see here kind of in sand 2. And then cluster 20 data points map directly to the top and bottom of sand 2, right? And so in a 3D space, if I now plot the points in the six clusters that were geologically significant in XYZ space, you see that you have forming here three distinct kind of bodies, and these actually represented the three sands that were known to be in that seismic volume. Right. And then after that, kind of what I said is based on the saturation logs taken from the well that penetrated these three bodies, I was able to interpolate saturations across the sands and ended up then with a data model that really flagged kind of wet versus gas zones. And what was interesting, so this is a proof of concept that I did in my first year. And what was interesting is that the fluid saturations match the accepted geologic interpretation for this sand. It was a little funkier for these ones, but it did match, for this particular sand. And I guess what this showed is that, Kmeans clustering workflows could actually help, not replace, but help in traditional kind of seismic interpretation. And the analysis that I did took, a couple of weeks versus screening of new seismic data, which could take months. Um, and also, there's the potential that the algorithm can detect patterns in the seismic attributes that may not be obvious to human interpreters. So you have the potential to unlock large value at minimal incremental cost, because the only cost associated with this was the cost of, kind of computation. So if you use like a high performance computer, it would be the cost of that. And I mean, I guess my salary, but let's be honest, small, right? I hope you all laughed at that as well. So that is this example. The other example is kind of shifting gears a lot, but it's a good indicator of, I guess, how different the projects, data scientists work on could be. The next thing that I'm going to talk about is a project on generative adversarial networks, or GANs, that was used to augment kind of training data. Now we're getting into a field of data science called deep learning. And deep learning is a type of machine learning that uses algorithms called artificial neural networks. And I'm sure you've heard about neural networks, but these neural networks are algorithms that are inspired by the brain. So if you ever see a neural net, it has, you have inputs, and then kind of inside the neural net would be these things called neurons that process the data, and then you have an output coming out the end, which is very similar to how your brain works, for example. It's not the same, but it's inspired by. And a GAN is a specific approach to deep learning whose goal is to generate synthetic data. So just keep that in mind, that a GAN, the goal of it is to generate fake data essentially. And this is an example of kind of typical GAN architecture. So you actually have two models, a generator and a discriminator. Now, the generator is like a forger. So you would give your forger some input, and it's going to output some fake some fake output. In this case, it's a fake image. The next part of the network is the discriminator, and the discriminator gets real images and fake images, and needs to tell you and classify which is real and which is fake. And as the training goes on, as you train your generator and your discriminator, the generator gets to be a better forger. It gets better at creating synthetic data, which at the end of the day is what you want. You want synthetic data that is so realistic that the discriminator can't tell that it's fake. And GANs actually have quite a few uses in geoscience. So one of the papers that I read was GANs being used to denoise seismic data. So essentially what you would do is input to the trained generator. So after you've done your training process, you have a trained generator, you can actually train it to take noisy seismic data and output clean kind of denoised seismic data. GANs, again, the whole point is to create synthetic data. So I've also read a paper where a GAN was able to generate realistic geologic facies as well, and which were constrained by well data interpretation. So something as specific as that, you can train a GAN to do. Unfortunately, in my case, it was not any sort of geoscience. It was actually
Khadija, did you drop off? Okay, apologies for that, guys. We seem to be having some connectivity issues, so just bear with us for a couple minutes, please. Thanks.
just me. Right. So this was just talking about progressive GAN, which was the type of GAN that we used in the end. And these are the examples of the fake images that we were able to get. So, I mean, it's incredible that we started off from noise, which is essentially just things that look like static, to eventually ending up with these images that are almost indistinguishable from the real wind turbine images that we had. um I guess the one thing to note about progressive GAN, so it was developed by folks at NVIDIA. So the same people who make the GPUs for your gaming systems and laptops and all that. And the reason that it's called a progressive GAN is because this is the generator and the discriminator that I spoke about before, and it progressively, each of the networks progressively gets bigger, and as they get bigger and kind of more complex, the image resolution increases. And so progressive GANs are probably the best way that we saw to stably generate high resolution images, right? Okay. Right. So the next thing, this was important, path to becoming a data scientist. So um, this, I should say, qualify the statement, is the conventional path. So people I've seen who I work with usually get degrees in IT or computer science or math or something like that. And a lot of them tend to do master's degrees in computer science or statistics or even data science, as universities offer degrees in data science now. And then it's also recommended that you gain experience in the industry that you want to work in. So in our case, if it's oil and gas, it's recommended that you get experience and you understand the oil and gas industry. But then, it's like, Khadij, what was your path? So I did, as was mentioned before, a bachelor's degree in chemical engineering. While I did learn critical thinking, I had almost zero programming experience. I did do math, because a lot of the algorithms are based on like linear algebra. So that kind of helped me out, but in general had no clue. My master's degree was in reservoir engineering, which, yeah, nothing to do with data science at all. But the good thing was that I did have experience in the oil and gas industry, so that I understood the types of data I would be seeing, and then I also understood the problems kind of in the oil and gas industry that data science could potentially solve. So there. And then I guess the thing that I wanted to emphasize is that the courses that I took to get better at data science, they were all online, freely accessible courses on platforms like Coursera, Udemy, Kaggle, and any one of you can start, if you're interested in data science, using any one of these platforms today. Kaggle especially so it's a website, and there are data science competitions. And you may think, okay, that's dumb, why do a data science competition? But leading academics and researchers, they all participate in Kaggle competitions, and it's an excellent way to kind of learn from the best in their field. But yeah, I just wanted to end with, if anyone is interested in data science, that it's very easy to get started, and very easy to just start practicing and learning all about it. And so that is it from me. That's the end of the slideshow. Thank you very much for joining. Sorry that there was a little technical hiccup, and please just feel free to ask me any questions. And I hope you enjoyed the presentation today. So yes, that's it from me.
Yeah, thanks a lot for that, Khadija. I mean, it was really, really insightful, good information, good stuff. And I think the part of it that a lot of people tend to be interested in is, what was your career path? And I'm happy that you highlighted that. So, as we mentioned in the beginning, if you all have questions, feel free to put it in the Q&A pane and we'll address them. So we already have a couple coming through, and I'll just read them out so everyone knows what the question is. So,
Mhm.
what skills or programming languages would you suggest for those training to become data scientists?
Great question. Python. I thought that was really blunt, but if you so I know some people use R, but from what I've seen and from what I've read, Python is the most common coding language that's used in data science. A lot of the kind of packages. So I'm trying to think things like scikit-learn, Keras, um, what's another one? Oh my gosh, Fast AI, all those kind of machine learning packages, they are written in Python. So yeah, Python is an excellent starting place, and it's also one of the easier languages to learn, because it's much more easy to like read by a human as compared to something like C. So yes, Python is my final answer.
Okay, yeah, that was actually a two-part question. So the
Oh,
second part,
sorry.
no, 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 that's fine. The second part is actually what sort of training did you go through? And I know you mentioned like Coursera and Kaggle and stuff, but is there anything in particular that you would recommend, like a progression going through? What sort of training did you go through?
Sure, no, that's a great question. So for me, even before learning anything about data science, it was important for me to learn coding. So I highly recommend anybody who is interested in data science to first be not an expert, but understand at least the basics of coding. So the course I used was the Udemy course called, I think it was Python Bootcamp from Zero to Hero by Jose Portilla. And that was a really excellent kind of crash course in Python. And then after that, I think I took the data science specialization from the University of Michigan, which is on Coursera. And then I think I did the deep learning specialization, which is an Andrew Ng course. And Andrew Ng is actually one of the founders of Coursera. He's a data scientist, like academic, based out of Stanford, in California. But yeah, so I think those are two that I remember. And then I think I did a bunch of LinkedIn learning courses, but the most helpful would have been that University of Michigan data science specialization, and then the deep learning specialization. And also, I just want to say that learning by doing is probably the best way to go about it. So that's why something like Kaggle, if anyone has done Kaggle, you'll know the Titanic competition where you predict who survives and who doesn't. That's like the first competition you do, but it really it kind of helps you put everything together. So while the courses and everything are good, doing data science projects would is even better. So so yeah.
Cool. Thanks. Another question we had was, what's the difference between data science and data management?
Shout out, I know who asked this question. Um, so data management is kind of exactly as it sounds. It's it's managing your data. So it's making sure that your data layer, that data backend has data that's in the correct format. It's cleaned. It's verified. What else? It has gone through like an auditing process, and it's to the standard that it should be. Now, that's data management. Data science is all about extracting value and analyzing data in order to gain insights. Now, you can't apply data science techniques without having a good data management strategy. You can't have images on five separate people's computers and then easily expect to do some sort of image classification data science project. So you need to have a good data backend, you need to have a good data management strategy in order to apply data science techniques on that data, if that makes any sense. I hope it does.
Yeah, I think that answers the question.
Okay. Cool.
We have one that just came in there. Let me see. So, how do you think artificial intelligence will impact oil and gas exploration and reservoir engineering in the future?
That is an excellent question. So the first one was drilling. I forgot the question, right? The first one was drilling, yeah? How
Yeah. How will it impact oil and gas exploration and
okay.
reservoir engineering in the future?
Okay, good. No. So I think in both scenarios, artificial intelligence, which machine learning is a subset, I think it will really improve very drastically the efficiency of data exploration. Now, what do I mean by that? So I talked about, for example, using that clustering algorithm to essentially screen seismic data quicker, in order to find the right hydrocarbon indicators, which would essentially kind of help you narrow down where to drill. And that's just one technique of a number of, I guess, artificial intelligence, machine learning techniques that are being used to speed up the screening process, in order to make it more efficient. So I think efficiency is going to be one of the biggest impacts. And then also I mentioned, gaining new insights that traditional workflows may not tell you. So again, going back to that clustering example, the fact that machines can see and analyze data kind of in a high dimensional space, which is this space that you're in seismic processing, when you have kind of dozens of seismic attributes that you're looking at, and machines are able to make those connections much quicker. I also think that kind of machine learning and artificial intelligence is going to play a role in unlocking even more value through that ability. um, in terms of reservoir engineering, I've seen, a big one that I've seen is around reservoir modeling. So specifically, so I'm just going to talk about examples that I've seen where you use a neural network and train and input hundreds of thousands of runs on from some 3D full physics reservoir model. You input specific reservoir parameters to that neural net, and and through that you develop a proxy model, so a model that's much simpler than your 3D full physics model, and it's much quicker, but it allows you to get kind of the reservoir performance through time similar to a 3D full physics model. So in that way, using machine learning and artificial intelligence, it's almost simplifying and reducing the time it would take in to do like a full physics 3D reservoir model, but still giving you, the reservoir performance that reservoir engineers would need to manage their reservoirs well. Um, yeah, so I think it's really about improving efficiency and allowing experts like seismic processors and reservoir engineer to spend less time less time doing things like manipulating data and more time analyzing the outputs of artificial intelligence in order to make better decisions. Yeah, I think that's what I have to say about that, which was a lot. But anyway,
No, I think the detailed answer would be appreciated. So
sorry.
we have we have one last question that we'll take. So the question is in the on the slide with the SpongeBob GIF or GIF, however you pronounce it.
I still don't know, man. Yeah.
Um, like what was the context of it? What was it meant to show in the flowchart that you had?
Wait, why was SpongeBob there?
Like, was the reason for the manic? Like, why are they running around like that?
Oh, okay, great. Wow, whoever asked that question. um, so it was really to highlight the fact that, since none of the project team had any experience with using GANs, and initially it was kind of like, oh my God, what are we going to do? How are we going to approach this? And it was really to highlight that, okay, you have that minute of panic, but then afterwards, as is typical in data science, you just have to try things until you find something that works. And this is something that, even more experienced data scientists will talk about. You're never going to know everything. The cutting edge of data science is always shifting, further and further. And so it really is about having the mindset where you're going to try and having an agile mindset of failing fast, um and just learning really quickly. So you have that minute of panic as SpongeBob and Patrick highlight, and then you just go about experimenting until you find something that works. Also, I really just wanted to put that in there. I mean, thought it'd be a good laugh.
Yeah, no, I think it gets the point across, to be honest. I'm not seeing any other questions. So Khadija, once again, I'd like to say thanks to you for taking your time to deliver this talk here today. And to everyone on the call, thank you all for attending and join us next time for our next talk.
Yeah, thank you all so much for having me. This was fun.
Not a
Okay,
problem. Thank you all. Y'all be safe. Have a good evening.
bye.